Okay, so we have to prove that the points A, B and C are the vertices of an isosceles right angled triangle. Also, find the coordinates of D so that ABCD is a square. Right? So let us first concentrate on the first part of the question. Let us draw ABC. Let us take a figure like this. Since the question is already asking us to prove that it is an isosceles right angle triangle, let us make a figure like this. Let us take ABCs, A, B and C. Okay, A is already given to us as minus 5 comma 4, B is given to us as minus 1 comma minus 2 and C is 5 comma 2. Right? So if we have to prove that some triangle is isosceles, we should show that two of the three sides are equal. And if we have to show that it is right angled, then we will have to show that that triangle follows the Pythagoras theorem. Okay, this is the major concept involved in this question, right? So since we are dealing with distance for isosceles as well as for right angle, let us go ahead and apply distance formula and find the lengths AB, BC and AC, all the three lengths, right? So just apply distance formula for AB. It will be under root of x1 minus x2 whole square plus y1 minus y2 whole square. So in our case it will become x1 minus x2. It will become minus 5 and minus minus plus 1 whole square plus y1 minus y2 4 minus minus 2 and minus 2 will become plus 2 whole square, right? So what do you get? You get under root of 4 square 16 plus 6 square 36, right? So this is under root of 52, correct? Further, let us calculate BC. BC is what? Under root of, again, x1 square, sorry, x1 minus x2 whole square, which is 6 square, right? Minus 1 minus 5 whole square is 6 square plus minus 2 minus 2 whole square, minus 2 minus 2 whole square. Now you should get again the same value. This is 36 plus 16, which should again give you under root of 52. Let us go ahead and calculate the length AC. AC is what? AC is under root of minus 5 minus 5 whole square plus 4 minus 2 whole square. So this will become under root of minus 5 minus 5 is 10 minus 10 and minus 10 square is 100 plus 4 minus 2 is 2, 2 square is 4. So this is what? This is under root of 104, right? So these are the values we have with us. Since we can already see that two of the side lines are coming out to be equal, so we have already shown that the triangle is what? Triangle is isosceles. Now if we have to show that it is right angled, let us see if it follows Pythagoras theorem. So if you look closely, you can very easily see that AC square is coming out to be equal to AB square plus BC square, correct? AC square is 104, AB square is 52, BC square is again 52, 50 plus 52 plus 52 is 104. So this equation is satisfied, which means that our triangle follows Pythagoras theorem, which is only true for right angled triangles, right? So this calculation completes our first portion, right? Second is what? Second is find the coordinates of D so that ABCD is a square, right? We don't know right now where D is, but we can very easily see that it would be somewhere here, so that the quadrilateral ABCD will become what? Will become a rectangle, sorry, a square. Okay, so now there are basically two approaches. Either I can consider D as x comma y and then I can use distance formulas. I can take AD and equate it with CD and I will get few equations which can be solved for x and y, right? But in this particular question, distance formula, using distance formula any further is not a good approach, right? What we should do is, we should convert this question into section formula, okay? And how to do that? We will have to use the property of square. The property of square is that the diagonals of the square bisect each other. So if the diagonals, let us say, bisect at O, then O is bisecting BD as well as AC, which means that O is midpoint of AC as well as BD. Okay, so let us calculate O first. Let us calculate the coordinates of O. Let us consider the coordinate of O is XO and YO. So XO is what? XO is midpoint of AC. So midpoint formula is x1 plus x2 upon 2. So if you add minus 5 and 5, it will become 0. So your XO is becoming 0. What about YO? YO is y1 plus y2 upon 2. It is 4 plus 2 upon 2, which is 6 upon 2 equal to 3, right? Which means that our coordinate of O is 0, 3. But this O is also the midpoint of BD, right? If O is the midpoint of BD, then we should get something like 0 is equal to minus 1 plus x upon 2, minus 1 plus x upon 2, which will give us x as what? X as 1, right? What about the y coordinate? Y coordinate of O is 3, but we can also get 3 by using y1 plus y2 upon 2, which is minus 2 plus y upon 2, which implies that y value should come out to be how much? Y value should come out to be 8, correct? So this should combine and give us the coordinate of D. Coordinate of D will become 1, 8. This is your final answer.